Hey, hi, Rajan this side. Welcome to my YouTube channel. So today we will discuss the fourth problem asked in yesterday's Codeforces round 1057. It's a diff 2 round. I already posted the solution video of first three problems. So today we will discuss the fourth problem asked. So it says there is a circular array B of length m, right? And this would be called nice if every element has at least one adjacent element equal, right? And this is a formal definition that doesn't matter. So ultimately the array would be called nice if every element has at least one adjacent element equal, right? And you are given a circular array a of length n, and in one operation you may increase or decrease any element of a by one, right? And your task is to determine the minimum number of operation that would be required to make the array a nice, right? And yeah, this is a formal definition. So yeah, so for example in this test case, if you see, it can be converted into nice array by two operation. First, make these two equal. So it can be made equal by either reducing 100 to 99 or 99 to 100. So either increase 99 by 1 or decrease 100 by 1. So once you do that, this is fine. Now you can either same decrease 3 by 1 or increase 2 by 1. So after the operation, the array would look like, so let's say you increased 2 by 1, then it would be 3, and let's say you decrease 100 by 1, so it would be 99. So this is a nice array because every element has adjacent at least one adjacent element equal, right? So for 99 this is equal, for 99 this is equal, and similarly for 3, since the array is in a circular order, so for 3 the first number would be the adjacent number, right? So they are equal. So yeah, I hope you understand this problem. So let's see how we can approach it. In the fourth problem, we know that for any number, at least one of the adjacent element has to be same, right? So let's say at any index I, your current number is x, right? So there might be a case whether either the next number is same as x or the previous number is same as x, right? So let's consider a case when the next number is same as x. So the next number is x. Now think about this number. For this number, see, our goal was at least one of the adjacent has to be equal, right? For this number, the previous number is already equal. So for the next number, it could be either x or y, right? So let's consider a case when this number is different, y, right? So for this number, it is okay, okay. Now for this y, consider a case if this number is y and we know that the previous number is already different, so the next number has to be y, right? Then this is also okay, this is also okay. Now if this is y, the next number could be either y or z. So let's consider a case when this number is y. If this number is y, then this is also okay, right? Because the previous number is same. Similarly for next number, it could be either y or z. So let's consider a case when this number is different, so it would be z, right? If this number is z and if the previous number is not equal, then the next number has to be equal to z, right? To make the array nice. So if you look at closely, this is a contiguous blocks of same numbers, right? So your nice array would look like something like a blocks of equal numbers. So I hope you understand this part. So your nice array would look like a block of same numbers, right? X, all are x, then all are y, all are z, p, q, right? So ultimately we have to convert the whole array into some blocks of same number. Now let's think about the size of these blocks, right? I claim that your block, I mean, the array would be converted into nice array if the block size is either 2 or 3. Let's see how. I know that the block size cannot be 1 because if the block size is 1, let's say 1, 2 and 3. So here the block size is 1, right? So the previous number is also different, the next number is also different. So this case is not possible. For block number 2, this is possible for sure, right? For the block number 2, let's say XX, YY. I know that both are good. They are good. Everything is good because the next number is at least one of the adjacent number is same. So block size of 2 is also fine. 3 is also fine. Now, the reason why I'm saying 2 and 3 is sufficient, let's say there is a block size of 4. So the block size of 4 means there are four number having same value. If the number is 4, I can easily convert into two blocks of size 2. So 4 can be converted into two blocks of size 2, right? So 2 plus 2. And similarly for 5, let's say there is a number, so 5, the block size is 5. So x, 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 x. I can easily convert into two block of one of size 2 and one of size 3. So that is why I said the block size of 2 and 3 is sufficient to solve this problem. So once you do that, this problem is easy now. So now it is converted into a DP problem. So now we will use a 2D DP. So DP of I, and let's say this is 1, and DP of I and 2. So DP of I1 will essentially tell you the minimum number of operation to convert sub array 0 to I nice such that at index I, the ith index and I minus 1th index, they are a part of block of size 2, right? I minus 1 and I. So 1 would represent for block size 2 and 2 would represent for block size 3. Similarly, this, the minimum number of operations required to convert subarray 0 to I is nice, such that your I minus 1, I and I minus 2, this is a block of size 3, right? And they are nice. So I hope you understand this part. So the recursive relation would look like so dp of I1, right? So dp of I1 would be absolute value of a of I minus a of I minus 1, because we know that we have to make a block of size 2, so this number has to be same. So just take a difference, and that is your number of operation required to convert both same, plus minimum of, so this is a block of size 2, so before that, I mean at index I minus 2, it could be a block of size 2 or 3, it could be either 2 or 3. So it's a minimum of dp of I minus 2, either block of size 1 or dp of I minus 2 block of size 2, right? So yeah, I hope you understand this part. So this is a recursive relation of dp of I1. Similarly, dp of I and 2. So for block of size 2, so we know that we have to convert these three numbers equal, right? So it could be either to convert same as first number, or to convert all three numbers same as second number, or convert all three numbers same as third number. So I'll create a function essentially that would tell me the minimum operation among all three possibilities. So let's say that number is k. So k plus, this would be minimum of dp of here I minus 1, I minus 2, I minus 3, this is I minus 3. So this is, so now at index I minus 3, it could be either of block 2 or block 3 size, right? So dp of I minus 3, or dp of I minus 3 1, or dp of I minus 3 and dp of I minus 3 and 2. So yeah, that's it. And one more thing, in the problem statement, this array is circular, right? So this calculation is going to be same. So there could be many ways, but what I did to solve this problem, I converted this whole array. So the array was from index 0 to n minus 1, right? So first I did all this calculation for this array. This is my first array, A array. I created a B array such that this is my index 1 to n minus 1, and then I kept the first number at the end. This is the 0th index. Now the third array which I created, that is from index 2 to n minus 1, and then index 0 number, index 1 number. So I created three vectors, I mean three arrays, and then I followed the same. So the answer would be minimum of among all these three numbers, because we know that the group size is going to be either 2 or 3. So that's why I first kept I mean I did a circular reordering by keeping first number at the end, then I did one more circular reordering by keeping first two number at the end, right? So that would take care of all the cases. So yeah, this is all about the explanation part. So now let's look at the code. So here is the code. So this was the function which I mentioned in the explanation part. So let's say there are three number a, b and c, right? And I want to convert all three numbers equal. So it could be either same as number a, same as b, number b, same as number c. So let's say there is a case when you plan to have all three numbers same as a. So in that situation your operation is going to be absolute value of a minus b plus a minus c. Let's say you want to have b to be same as all three numbers, so y is going to be absolute value of b minus a, b minus c, and similarly for c, and just return minimum of x, y and z, right? So yeah, now let's come back to the original solution of this problem. So this is my input and this is the input array a, right? So first I this was the recursive relation which I discussed in the explanation part. So first I get the answer for this array a, right? So let's see what I'm doing here. So here I created a vector of so this is my dp array, right? So dp of I1 for block size 2, and similarly dp of I2 for block size of 3, right? So for dp of 1 1, for dp of 1 1 means index number 1. So there are two number, right? Index 0 number, index 1 numbers. So there the number of operation is going to be absolute value of a of 1 minus a of 0. Similarly for 2, dp of the indexes of the array are 0 1 2 3 up till n minus 1, right? So similarly for in dp of 2 2, dp of 2 2 means you are taking all three numbers. So that's why I call this function fun of a0 a1 a2, right? Now from index 3 onwards, right? So dp of I1 is going to be, so dp of I1 means a block of size 2. So this is same as the explanation part, so please check it out. So dp of I1 is going to be, I and 1 is going to be a block of size 2. So absolute value of a of I minus a of I minus 1 plus minimum of size 2 at size 3 at the index I minus 2. Similarly for 3, for block of size 3, block of size 3, correct, yeah, dp of I and 2. So 2 is for blocks of size 2. So that is going to be the minimum of fun of these three numbers plus dp of I minus 3, 1 and 2, right? So and at the end just return minimum of n minus 1, I mean the block of size 1 or block of size 2 or block of size 3, right? So yeah, I hope you find this video helpful. Please like, share and subscribe to my channel. Thanks for watching.